Okay, so today in lesson 5.5, we're going to be talking about taking the derivative of bases of exponential functions with other bases in e and log other bases of e. So we've only done natural log and common log. So we're going to move on to a derivative of functions like 2 to the x, and logs will make common log, base 10, base 2, etc. And so we need to figure out what to do. So first of all, let's remember what we already know about how to do these things. So this, in our brain, we can think about the rewriting process. This means 3 to what power is 9? And of course the answer is 2. And so we're looking for 2 here. So you can do it that way, where this is a different way of kind of thinking about it, rewriting it as log base 3 of 3 to the second power, pulling the 2 in front, and then log base 3 of 3 is 2. You can do that, or you can rewrite it as an exponential function in the first place. So like this one is back forth to that one, and so on. We kind of already know this. Again, we're just reminding you of something you already know. How do we then solve equations? This is a pretty simple equation. This is asking what power do we raise 6 to get 36? And the answer is 2. This is a little bit more complicated because you've got the 2 arguments, but the log base 3 of 9 is 2. And then you'll need to move the 2 over. And we've got factoring, so we factor. And so those are our 2 answers. We have to keep in mind what's going on here. If it works, the idea is that it will be 2, 1 squared plus 1. So yeah, they're both going to work just fine. This one's a little bit trickier right here because there is no way to rewrite this, but we can think of this as 2 to the equals 2 times 5 squared. Not sure if that's actually helpful, but it is something we can do. If we take the natural log of both sides, this is where we get, because the other way there's not really any way to do this. We can also do this with common log. They could both have common log in front, and it'd be the same thing. Then use your calculator. So not the end of the world. We already know that the derivative of e to the x is e to the x. And so the question is, what is the derivative when the base is not e? So when it's not a base of e. So that's the question. We'll start with this. And so we're looking at this. We use implicit differentiation. So we're going to have 1 over y times dy dx equals x. Actually, the derivative of that is just the natural log of a, because it's just, and then dx if you want. It's because this is a number. That's what we have to remember, is that's a number. And it's really easy to forget that. My first reaction when looking at this was, oh, I guess I probably should do product rule. But then I remembered a is not a variable, a is a number. And so the natural log of a number is a number. And so basically this is like 3x, but this is not 3 because we don't really know what a is. So that's kind of the idea there. And so natural log of a. And so then we end up with dy dx equals y times the natural log of a. And dy dx equals y was natural log, was a to the x. So a to the x times the natural log of a. So kind of let that sink in for a minute. What happened here is we've got, so if I were to challenge us with, let's say we had this and I asked you for dy dx is equal to 2 to the x times the natural log of 2. And if you think back to this rule up here that we already know, if we use that and we said, okay, so what's the derivative of e to the x? E to the x times the natural log of e, and the natural log of e is 1, and that's what's happening. So it's the same idea, it's the same concept, and a lot of those same things happening. So let's just see if we handle that a slightly different way. What do we know about the natural log of a? It's that it is a number. So we use implicit differentiation there, and we solve, and so there's our rule. The derivative of any base other than e of a to the x is a to the x times the natural log of the base. So this is the one I did a minute ago, so we'll move on to a different one, just quickly reminding you. 2 to the x times the natural log of 2 is f prime of x. Okay, and so now what about that one? So this one's a little bit trickier. We're going to take 5 to the 2x times the natural log of 5. That's our rule. And then we have to take the derivative of this, which is 2. So we end up with 5 times 2 to the x times 2 times the natural log of 5. This is just a number, and that's our derivative. Pretty straightforward, nothing tricky going on there. All right. Weird. Let me see what's happening next. Give me a minute. One more example, this would be integration. And so the integral of these, so we've got these two different ones. They're very close together. So you can break it into each piece. Then you can move the pieces together. And I don't know. Oh, and so then we take from 1 to 2, and then we have already from 2 to 500. So this one from 1 to 500 of 13x became from 1 to 2, and then 2 to 500. So that's the same. Then we have these two. And then this one of 1 to 500 of negative 11 to the x becomes 1 to 2 of negative 11 to the x, and 2 to 500 of negative 11 to the x. And then these two should cancel each other out, so that we're left here with just 1 to 2 of 13 to the x dx, and minus 1 to 2 of 11 to the x dx, which according to our calculator is that number. So that's just a way to kind of manipulate it. Of course, we could have just grabbed a calculator right from the beginning, but the idea is that we can remove the end part of it because of the way it worked out in this particular situation. So that's where we're going to stop today. If I decide a little later to add some more, I'll add some more, but I think it's the end. It looks like this is the start of our next relationship, and so we will finish this when I get back.